Yeah, can I start? Okay. So, hello everyone. So this one will be in English. I hope that's okay. So I will be talking about Lidars. Lidars have been used for several years to perform wind resource assessment. And so I come from Barcelona, the Lidar manufacturer that you might know. My name is Julian Beckton, and I will present two types of usage application of Lidar adapted to Turkey. One is for complex terrain onshore, and the other one is for nearshore, offshore wind resource assessment. So briefly, for those that don't know Vaisala, we're a quite big company, worldwide company, with the headquarters in Finland. But all the LiDAR manufacturing capabilities, R&D, service center, everything related to LiDAR is based in France, in the Paris region. But we have also service centers all over the world and more than 400 partners. We also have partners, of course, here in Turkey. If we look at the Vaisala and the type of products we make, we are manufacturers of environmental sensors. Here you have some of the sensors we manufacture, weather stations, visibility sensors. They can be found everywhere, like in airports, wind and temperature stations for forecast. And we also have intelligence platform using data for forecast. For example, it could be for lightning, it could be for icing, and other type of data intelligence that we provide to the world, because we have a spread number of sensors all over the world that allow us to predict what's going on with the weather. But today I will focus only on the LiDARs part. If we look at the instrument itself, for the LiDARs on the left, we have, let's say, 3 series of instruments. You see 4, but there are 3. So the vertical profiler, we replace the MedMap, the onshore, and then the offshore version. Then we have the wind scan. It's a long-range scanning LiDAR that allows you to measure really far. And the wind nacelle that goes on top of the nacelle of the turbine, usually for a power performance curve or for turbine control. And then, of course, we have the software, and the newest software we have is called Compass. It's a cloud software that allows you to control the fleet of LiDARs and also allow us to implement new modules easily and quickly, so you can process the data in a different way. So if we now take a look at the challenges we've seen when performing wind resource assessment, one of the requirements we have from the market is that you need more and accurate wind data to minimize the project risk, to get better financing, to improve profitability, better calculation of AP, of P90. The other issue is that deadlines are not tall enough. Turbines are growing. You need to go higher. You have, I saw from the plane, a lot of turbines on the mountains. You need tall medmasts, difficult to install, difficult to have permits. So LiDARs allows you to kind of break this barrier. As I just mentioned, the turbines are growing more and more, so the requirement of measuring at half height becomes really challenging with medmast. The other fact is that you want to make sure you're using the best practices and adhering to health and safety conditions. Installing medmasts in difficult places can be tricky, and of course you want to make sure you achieve bankability. And at the end, what you want is a partner that gives you certainty about the results and about the measurements, and about the fact that at the end you could get the money to finance the wind farm. So let's now dig into the LiDAR itself. Here we have a picture of it's called WindCube. It's a vertical profiler, so it's measured vertically, replacing the bedmast. And really briefly, for those that don't know how the LiDAR works, the WinCube and all the Lidars in Vaisala are using the Doppler effect, which you might know from the acoustic, the car coming towards you or moving away from you, you have a different frequency or the ambulance. This is the Doppler effect, a change in frequency. So the same idea is applied to yeah, I guess.
Sorry.
It's not mine. So the same principle is applied to the lidars, but it's optical. So what the lidar is doing is sending pulses of light to the atmosphere. In the atmosphere we have aerosols. Aerosols could be dust, sand, different type of components. These are moving with the wind. So the light, it's bad scattered to the lidar, and there's a shift in the frequency similar to the one I showed in the slide before, and this shift is proportional to the speed of the wind. So this is a really precise way of measuring at high height. So with the WinCube you can measure up to 300 meters with the same resolution you will have at 50 meters. So now let's move to one of the applications that might be more interesting for Turkey, which is complex array. So here you have a picture of an installation in complex array. WinCube is probably used in complex array because it's much easier to install. And sometimes it's used collocating with a medmast, and I will talk about this later. So we have two main tools to support wind resource assessment in complex array. The first one is the complex array estimator. It's a tool that we have developed that allows you to know in advance how complex is your terrain with respect to the lidar. When you use a lidar in complex array, you might need to do some corrections to the measurements. This allows you to know if you need correction, if you don't need correction, and where to install it in advance. And also you can know in advance if you will have extra cost to do this correction. And the other thing that we have in the WinCube, the second part, is the flow complexity recognition, FCR. This is a correction to the lidar measurements to complex array, to slightly complex array that is already embedded in the WinCube and included with all WinCubes. In the case of using another lidar manufacturer, for example, you will need to pay extra to a third party to do this correction. In this case, it's included in the lidar. And here you have an image of a simulation of the complex array estimator. It's a complex tool using a neural network. It's not only looking at the slope of the terrain, because it's not the only thing that matters for the errors. So if you're in a green area, you could say it's flat, so you don't need any correction to the measurements. If you're in the yellow area, it's slightly complex, so you can use the embedded correction. And if it's really complex, you need to use a third-party supplier doing CFD, so a more complex solution for the correction of the measurement, which is a common practice in the field. So here we can see all together these three different approaches. So if it's green, it will be the top. You can consider flat. You will have the lowest uncertainty. If it's slightly complex, it will be number 2. You can use this correction that is embedded in the WinCube. And if it's a third, which is really complex, you will need to use a third-party CFD correction, so a more complex flow correction. And I have included here a use case in Croatia where they had a complex array, a really quite complex situation, and the issue they were having is that they were not able to install a tall medmast. They needed to measure higher to reduce the extrapolation error, the vertical error. So what they did is they put a medmast, a lower medmast, 60 meter, and they put next to the medmast a lidar. So you could compare the lidar at 60 meter with the medmast, and then you can use the lidar at high heights, and you can reduce extrapolation error, and you can have a better P90 and a more financial conditions. The next topic I'd like to cover is offshore. I think offshore in Turkey is something that is developing, so I will present this approach, which is called dual scanning Lidar, which allows you to perform wind resource assessment from the shore without having to deploy Lidars offshore. Here I'm showing you this picture. These two Lidars will be on the shore, on the coast, and they are pointing to the sea and allows you to perform this measurement. And for this approach, what we're using is the wind scan. It's this Lidar here, which is a long-range scanning Lidar. You can see the optical head allows you to turn and to measure at different directions and locations. You can schedule different type of scanning strategy, measuring at different points, and you can measure up to 18 kilometers from the shore, depending of course on the environmental conditions. Usually the typical range would be 10 kilometers. So in case you're developing a wind farm near shore, let's say 10 kilometers from the shore, this is an approach you could use. And the idea is presented here. Two scanning lidars are placed on the shore, and they are pointing towards the sea, and they point at the same location and at the same time. So it's a synchronized measurement that allows you to get a good accuracy for both wind speed and wind direction, and also for turbulence intensity. You can create what we call a virtual landmass. That means lidars pointing at different locations. And this is an application that is really growing acceptance in the world. It's been broadly used, especially in Japan, and there are some projects in Europe and as well where they were able to achieve good financial conditions for the development of wind farms. I have included this slide where we can see what the advantages of this approach with respect to other approaches will be. For example, deploying a LiDAR offshore, or, well, it's quite strange, but installing an offshore landmass, but that would be quite rare. It's easy and fast to deploy. You have lower operation costs. You don't need to wait for the sea to be calm to go and to install the LiDAR. You can do it on the coast. Not many, you don't require really big permitting, it's just installing a device. There's a low environmental impact. The accuracy you get from this measurement is extremely high for wind speed, wind direction, and turbulence intensity, and you improve the risk profile and the project bankability, because you will have a lower uncertainty, a higher P90, better conditions for the loan to build a wind farm. This dual scanning lidar solution is really mature, and especially in Japan, where we have deployed more than 100 wind scan, so more than 40 dual scanning lidar campaigns have been performed in Japan, where they obtained in several places the certification from the local auditor, which is called Class NK, to validate these campaigns. And there are also protocols written by the Japanese to explain how to perform these campaigns. Here you have some of the projects that have been developed, for example, in Japan. You can see a lot of green points, and most of the offshore wind resource assessment for near-shore wind farm development has been done using dual scanning lidar, and this is because of the conditions, which might be similar to Turkey. They have a lot of near-shore projects. They are located in an earthquake zone, so doing things offshore really far is difficult. And the other factor is that they have a strong wind variability, which is also common in some parts of Turkey. Using dual scanning lidar allows you to measure at different points, so you can see the variability and you can improve the location of the turbines in the future and produce more. Regarding the acceptance of this solution, DLB has worked a lot on dual-scale Lidar as a certifier, and end of last year they released a technical letter where they have validated this approach, and they give confidence to this approach by saying that the well-designed campaign can be performed use DSL as a standalone solution. That means without any other measurement, providing of course the campaign is performed correctly, which is something DNB are allowed to validate. And just to finish about the dual-scale Lidar and about some of the projects are not public, so there's limited amount of information, but this is some of the public information that we can find online from different biggest Western developers using dual-scale Lidar. Total Energies is one of them, and some of these projects are actually performed in Southeast Asia. We have also WC. We have this project from Carbon Trust led by RWE, where they use 7-week scan to measure blockage and weights. So all this shows that the interest on this technology is because it's really profitable at the end, and you get better measurements. So that's all for me, and if you have any questions, please reach out to me. You can talk now if you want. If you have any questions, and yes, you have a question.
Am I right? For the complex terrain, this is not a good solution, I think. Is that right?
That's what I said during my talk. It's a good solution. Why?
But you said before in that section over here, yes.
This one?
Highly complex terrain.
Yes.
In Turkey, we have many highly complex terrain.
Yes.
Onshore.
Yes.
That's the reason we need, of course, like that equipment. But we have an achievement or not, we don't know it exactly.
Oh, so that's why if it's highly complex terrain, which is a quite common case in Turkey, what you would do is use.
They have to use. You mean a MadMast, right?
No, you can use
this one.
Usually, it depends on the certifier. What you will need is to combine. For example, in the case of Croatia, they put a small MadMast. You put a LiDAR next to the MadMast, so you can compare the measurement of the LiDAR to the cap of the MadMast as a reference just to validate, and then you use the higher measurements from the LiDAR. But you might need, depending on the complexity, a correction, a CFD correction, which is performed by DNV, Deutsche Wingard, different companies, Metadyne. They correct for the complexity of the terrain. And this is a common practice. And it's possible.
That's approved by bankability report?
Yes and no. It depends how much pressure you can put on the financial institutions, but it will depend. So if there is no, today there is no standard around that. For example, in Germany, they're using it as a way to promote this technology. So it depends on how well it's explained to the financial institutions, how much they understand about the technology. I'm not saying
you know the banks, own financial companies, as you know.
Yes.
It's acceptable or not?
Sometimes it's acceptable, sometimes not. It depends. It's a negotiation to have with the financial institutions. It depends on the country. In Germany, they will accept it. In some countries in Europe, they won't accept it. In some countries, they will accept it. In South America, it will be difficult because LiDAR is a new technology. It depends.
They don't know it very well.
Yeah, so they won't. They struggle to accept even flat terrain. So it will depend on the location and how much support you get from the certifier. For example, DNV could do this CFD. If then you go to the
It's a
financial
good reference.
yeah, if you go to the financial institution and you do it, it's okay. But if you use your CFD using freelance from that no one knows, and you go to the financial institution to ask for money, tell you, who is this guy?
Of course.
So it depends. That's why it depends how much support you have from the companies doing this approach. Yes.
Hi, this is Boris from UI Solutions. We are working closely with Faisala in Europe and sometimes in Turkey we are attending to, but unfortunately because of this complexity we cannot. But first of all I would like to thank you for your presentation. I had a chance to keep up with the latest updates. My question as well with regard to this page of the slide, but I was wondering a little bit more technical detail, which is the CFD. I have several questions, but I will not ask all of them, not to take too much time. The CFD is performed by Vaisala itself, or you are having consultancy services? And is it the correction of the measurement is limited to CFD only? Because if you know us a little bit, we don't use linear or non-linear method by calculating the inflow modeling. So I was wondering if this correction method is limited only with CFD or can be done with any other inflow modeling such as mesoscale based.
Okay, first, no, we don't do CFD. So CFD is it's a complex, it's the solution of the Navier-Stokes equation, which is quite complex, the non-linear. FCR will be the linear.
Okay, may I interrupt here because it is important for me. So you, in this specific example, you, the lidar can be placed in a complex area without a mast or with a low net mass, which is 40 meters in the Croatia example. So for CFD, according to my experience, you need to have a very good and quality measurement. And if you are considering correcting something with CFD, you need to have a good and quality measurement.
Yeah.
Now we place the lidar in a complex area, and we are planning to correct it with a net mass, which is 40 meters. And in a complex area, you need to have the measurements at heights. You need to be sure because of the shear as well. So how do you rely on the CFD for such sites, and how do you reflect the uncertainty resulted from the CFD in your overall and final measurement campaign?
Okay, that's a complex question.
Yeah.
So again, we don't do the CFD, so in our measurements we are not taking into account the CFD correction. So basically the CFD will take the orography of the place, the different beams of measurements, and they will correct to make sure that you're getting the right angle for the wind directly, and then they will apply directly the correction factors to the data. So we are not really involved in that.
Okay, the corrections apply to the main component of the wind, including vertical and the horizontal wind. Because in the end, what we are using in the energy analysis is just the horizontal.
No, it won't be the horizontal. The vertical no one cares. So it's the horizontal.
It is applied to
the correction factors. The CFD suppliers like Metadine or DNV or others they provide is for the horizontal. But they will take into account the orography and they will correct for the errors that you can see here. So they will take into account the four beams. The four beams are pointing in different directions, so it might be the land will be different in different locations. So this will be taken into account in the correction.
Okay. Last and very small question too. The complexity of the area is calculated by Vaisala with respect to the net mass location, right? So you are estimating the complexity of the site.
This one, you mean?
Yeah, it might be related to this one or in general as well. So to decide, or yeah, maybe it's more related to this one. To decide if the FCR will be deployed in the lidar, you need to calculate the complexity of the site to find the best location of the lidar. with regards to respect to the muscle?
My advice is for everyone to activate the FCR option.
All the
Just in
time.
case. So you get both corrected and uncorrected. If you use this estimator, you will know if it's enough or not in advance. So let's say you're in the yellow-green area, okay, you know you need FCR, but you're close to red, you know you need CFD.
Okay. These percentages are the slopes only? Or
It's the uncertainty error. No, it's different. It's related to the uncertainty, not to the slope. Because this calculation is not only the slope, it's also taking into account the windrows and the possible deviations using historical data, ERA5 data. It's a combination. If you give me your contact information, I can send you more information on how it works. And the FCR is the linear solution of the Navier-Stokes equation. It's the simplest approach.
okay, thank you.
Two small technical and one a little bit more commercial. I'll keep it short. One, you said we are quite accurate on the measurement, and my question is why do we need the methods if we are sure we are accurate? What is the reason that we need this different?
Historical reasons, change, takes time. So it depends on the type of terrain as well, but it takes time to convince people that the magical box sending light to the atmosphere is measuring something.
Okay.
I think it's more like the band mass is easier to see. You have something rotating, a car, it's easier to imagine. But then you're talking about the lidar sending light to the atmosphere. So there's some convincing to do, and there's also an AEC that will be released hopefully soon.
That's the third question.
That's the second question. Okay. One of my colleagues is actually part of the Black. He's part of the AEC committee, and they are currently writing the AEC, which is really based on the TR6 in Germany, which is the base for the Windows assessment. So this will be hopefully released end of this year, maybe. That's the second question. The third question?
Second is there any loss of accuracy as we go higher? Same point or if the weather condition change? Because if it's raining or snowing.
So in terms of the lidars measure a volume, which is related to the pulse. In the case of the pulse lidar, the higher you go, the same volume you have of measurement. If it's a flat terrain, there shouldn't be any impact on the uncertainty. However, the higher you go, the less light you have, so you have a bit less availability, and that might have an impact on the accuracy. But in general, it's actually, if we look at the classification data, the classification of the wind cube, it's actually lower because you have less shear effect at high heights. Because at low heights, you have the nonlinear part of the shear, which has an impact on the uncertainty. So the higher you go, in theory, the better, but then you have a bit less light, so there is no yes or no answer. It depends on the conditions.
With the weather conditions?
With the weather conditions, you might have less light, depending on the less availability, and you might capture a bit worse the wind variability, but it remains quite good. And we have actually, I haven't talked about this today, but we have developed a few tools to kind of compensate for this loss of availability. Not doing any gap filling, but we are quite conservative about the data we provide, and we can give much more data, and the data will be good. So we're
and I guess if you can reach 18 kilometers horizontally, it's not a problem to reach 150 meters vertically.
Yeah, it's a different, because when you go horizontally, you're using a 200 meter length pulse. In this case, it's 23 meters. So you have 8 times less pulse duration, which go to the square because of the energy. So, yeah.
The last one, which you already touched, is the IC standard, because in our sector, what is interesting is to do to provide service for the power curve guarantees of the suppliers. So, what is the plan for the IC? I understand there is no IC approved method yet for power performance measurement.
No, there is for power, yes. For power performance, yes. You have the wind cube nacelle, so the nacelle mounted lidar, is already approved as a way of measuring the power curve. The other
Standalone or with the map?
standalone.
Standalone.
But the other issue is the contract you have, or your customers have, with the turbine manufacturer. Because that's part of the contract with the turbine manufacturers, and you have here Intercom, and you can ask them what are the conditions. In the contract, they will say, we accept power curve measured with this and that. If they don't accept it with Lidar,
Usually they accept if it's IEC approved. So if the LiDAR is IEC approved, there can be pressure on them to accept it. This is why I'm specifically asking for the IEC.
I know there's an IC for power performance. There's also a guideline from Carbon Trust to use scanning LiDAR for power curve as well. This is not IC, but of course different. But for power curve, for the LiDAR, for the NASA mounted LiDAR, not the vertical
Including
performance.
complex terrains?
In complex terrain, I'm not sure. I don't think so. Probably not. But what I know is that even if there's an AC, some turbine manufacturers they don't want to hear about LiDARs. Yeah, no, but even if not for complex terrain, but flat terrain, even if it's there, you have here in Turkey you have a lot of Nordex turbines. I'm not sure if Nordex are really that positive about usage of LiDAR for power performance. I think it's
I'm sorry, but we have to complete special to prepare for that.
yeah. Well, we can talk later if you have any questions. And well, thank you very much for the invitation and for your questions. Thank you.